Welcome back, mathematicians. Today I wanted to look at the rational root theorem. So the rational root theorem is a way to kind of narrow down the possible roots or x-intercepts for our function. So here's a function. Here's an example. Um, and it may look like, hey, we can have infinite functions here, but really, there's only a handful of functions that we can possibly have, right? So what the rational root theorem says, right, and you can look it up in your book, is that P over Q for and basically the last term, right? So I'm going to change here. The last term I have right here, 35, over the first term I have, which what I mean is the coefficient, right, tells me all the rational roots I could possibly have. So in this case, I have 35 over 1, but then I have to think about all the possible rational roots I can have out of 35, right? So I can think of the easy case, right? I have plus or minus, right? It's real important that you put the plus or minus. It could be either of those. 1 over 1 or 1, that's equal to 1. I'm going to put this one on this end just to give myself a little bit of space. I have plus or minus 35 over 1, or 35. I can have plus or minus 5 over 1. And I can have plus or minus 7 over 1, right? So those are all the possible rational roots I can have. And really, I mean, if you look at that, that's a list of 8 things, okay? We could try out each one of those, or, right, if I'm trying to look for all x-intercepts, I can actually use my factor theorem and try a few out, right? So if I use my factor theorem says if I do f of 1, say, right? So that's one of my possible roots I could have. I plug that in. 1 cubed minus 1 squared. And again, make sure you put your parentheses. 37 times 1 minus 35. And then let's simplify that a little bit. 1 cubed is going to give me 1. 1 squared is going to give me 1. Negative 37 times 1 is going to be negative 37. And minus 35. Already I can start to see some problems here. I have only a positive one, and then I subtract something, subtract something, subtract something. And these are all greater than 1, or equal to or greater than 1. So I'm going to say that this is that x equals 1 is not a root. Okay? It is not a, let's call it x-intercept just to keep things consistent, right? X-intercept. All right. So let's. I made the problem, so I have a feeling this one might work. Okay, so let's try it out. Negative 1 cubed minus negative 1 squared minus 37 times the negative 1 minus 35. Let's try it out. All right, so let me scroll down here a bit. So negative 1 cubed is negative 1 times negative 1 times negative 1. So that's going to give me a negative 1. Minus negative 1 squared. This time is negative 1 times negative 1. So that's just going to give me a 1. This is going to be negative 1, or negative 37 times negative 1, which is going to give me a positive 37. And a minus 35. So again, all I did was check these first two terms right here, negative 1 and positive 1. And this first one didn't work out, right? But look at this next one. Right? So I have negative 1 minus 1 plus 37 minus 35. So some of you may already see a solution, but just in case we don't, let me simplify it some more. It is equal to 37 minus 35. And look at that. Again, if we can't figure it out just yet, I'll write out the last step. And then we have this guy equals 0. So this is one of our x-intercepts, right? So in other words, x is equal to negative 1 is an x-intercept. Well, how can I use that as a factor? Well, one of my factors then, I'll add 1 to both sides, right? and I'll get x plus 1 is equal to 0. Right? So that is one of my factors there. Okay. So what can I do with this information? Well, let's get a new page here. Oops. If I know x plus 1 is one of my intercepts, I can use that information, right, in synthetic form. So I can use -1, and I can use my function, right? So I have 1, -2, and I can just use synthetic division. Oops, hold on 1 sec, sorry. 1, -1, -37, and -35, okay? So I can go -1, and again, synthetic division, so I have 1, -1, so that's -1. Oh, that's -2. Not a problem. -2 times -1 is +2. This is -35. -35 times -1 is +35. And just like I expected, there shouldn't be any remainders. If you get a remainder, you did something wrong in here, or this isn't one of your x-intercepts. Okay, so that's a good way to double check. So this is equal to x squared minus 2x minus 35. And at this point, I can check some of my other roots, right, or some of my possible x-intercepts from the theorem, or we have other tools for this, right? So let's check to see if it's factorable, right? So can I multiply to anything and get a -35 and add to get a -2? Let's see. 1 and 35, of course. That doesn't look like it's right. I want a negative, so these are probably going to be negatives over here on the bigger side. 2 doesn't work, 3 doesn't work, 4, and then I have to go all the way down to 5 and 7. But this pair does work. So again, if you don't remember, we draw a little x here, -35 on top, -2 on the bottom. I have a +5 and -7. So my factors are x plus 5, x minus 7, and this term right here that I had before, x plus 1. Okay, so that's how you use the rational root theorem to get all the factors out of a function. So these guys are equal to that guy. So thanks for listening. I'll catch you on the next video.